Hello and welcome to the second lesson of the OpenCL C++ API tutorial. In last lesson, we just understood which platforms and which devices exist on my system of type GPUs. Today, we are going to use this data to actually compile a kernel, OpenCL kernel for the devices I have. Just make sure to take a look at the new project structure as I've moved each lesson to its own Git branch so you can access it easily. So how I'm gonna build a kernel for a device in OpenCL. Basically, kernels are the codes that we run on OpenCL devices, for example GPUs, and we can understand that each code has to be compiled for a specific device, so the compiler should exactly know which device it is compiling the code for. So the class that helps us in this for this purpose is the context device, and the context device is what we are going to create after that we know which device we are using. So I'm going to just instantiate it, and if I look at the constructor, I can see that it just accepts the device. So if I'm going to pass my only device and system of type GPU, now the context is created for me, and this context is what I'm talking with on behalf of my device. So if I'm gonna to pass arguments to the device, as we will see shortly, I'm gonna use this. If I'm gonna to compile code for this device, I'm gonna use this context, and so now I'm gonna to compile a code for my device now that I have context, and in this class list, the class program is going to help me. And if I look at the constructor, I see that the constructor of program, one of them, gets a string of source code and some other things, and I can pass context as well, that it knows which device it should build the kernel for, or if I don't pass it, it's just gonna to assume a default device. So I'm basically going to create a program instance here. Now I'm going to pass context so that it knows which device my program is supposed to work on. Now I'm going to pass the source code of my application, so I can just come here and write something, and code here it's just the basic string, but it may work for the small kernels, but for large kernels this can be errorsome. And so basically what we are going to do is to write our kernels in an external file of type CL to be clarified and to enable code editors to do syntax highlighting and things. And in this we are going to write the kernel code, and OpenCL code is a superset of the C99 code. So basically what we are writing here is a C code with the extension that OpenCL has and that we are going to get familiar later on. But for now, what I have written is just the hello world. As you can see, if you don't see this, if you omit this line, it's just a simple hello world. Now I just add this line 2. We will talk about it shortly, but for now let it be here, and this is my kernel. So what I'm basically going to do is to open this file, load the content, and pass it as a text to the program. So you can do in whatever way your IDE or operating system lets you. I'm going to use the Qt way, and I'm going to pass it. So and there is a boolean here. I'm going to use this constructor, and the boolean as the third parameter, which tells us to build it or not. We want to build it, so yes, we're gonna say true. There is a macro for that in OpenCL, and there's a error part, so I'm gonna just of type CL int. So I'm just gonna define it and pass it. So that's it. What basically have here is my kernel compiled for my device, which is in my context. So now I can run that code on my device. And there is one final step we have to do before we can actually run our kernel, and that is to build a kernel. So if I come here, there's a kernel class. The final result of my program is my kernel. So the kernel class accepts a program, a name, and an error. So the program is the program that we just made. The name is the name of actual function it has to run in that program, and the error is error. So what I'm going to do next is to create kernel, pass program. I want to pass a name. If I come here, I will see that the name of my kernel is test. So I'm just going to pass test, and again error, and then I'm going to run my kernel to see if it actually works. But before that, let's run just this and see what happens. So I'm gonna just to print the error codes here. To see what happens if things go wrong or right. So I have two printfs here actually. Now let's run it. If we run it, we will say that you will see that I get 1 0 and 1 minus error. So anywhere that in OpenCL that you get a 0 error, that means success. So that means that my program instantiation is good, but my kernel instantiation is not. And what are the meanings of these minus numbers? We are going to find out shortly, but let's make program fail. So I'm going to add some garbage code here so that my kernel doesn't compile. You see that the program error is minus 11. So how I'm going to find out what his minus 11 means? I'm going to use Google and just Google for OpenCL error codes. And I'm going to open the first site. And here you can find the table which lists out all the possible errors. So minus 11 says that we have a build program failure. So as we could understand, it actually means that there is a syntax error in our code. So I'm going to fix it and run my code again. And there is a minus 46 here that I'm going to find it, and it says invalid kernel name. So what that actually means is that my kernel name is wrong. So either this test does not match the name of my kernel there, or there is something else wrong. So if I open here, I see that test is test, but I said that there are OpenCL extension to the C. So here is one that you are gonna learn. I have to put this double underline kernel keyword here so that it be recognizable as a kernel for OpenCL compilers. So now if I run my code, you will see that both are passed. So basically what we did here is that we create kernels and We create a context, a program, and a kernel. In the next lesson, we are going to actually run this kernel and see what's happened there, and see from now on that we have compiled our kernel for our device, what extra steps should we make in order for our kernel to run. Make sure to like and subscribe and stay tuned.